Okay, so here we go. So here I have 7 to the n minus 2 to the n and show it's divisible by 5. So let's show true for n equal 1. So I have 7 to the 1 minus 2 to the 1 is equal to 5. Yes, that is divisible by 5. Check. Okay, so assume true, n equal k. 7 to the k minus 2 to the k is equal to 5. P, an element of the integers. Okay, so remember that's what I want to use in my inductive step. So I want to show true for n equal k plus 1. So 7 to the k plus 1 minus 2 to the k plus 1, and I want to show it's equal to 5r, say, r, an element of the integers. All right, here we go. So again, taking this, I want to get to the point of using this, remember. So you have to keep an eye on how can I possibly use this. So that means I'm going to need to peel off a 7 to the k and a 2 to the k. So let's do that. So I'll have a 7 times 7 to the k plus a 2 times a 2 to the k, right? Okay, so let's first off, how about, because I want to have divisible by 5, I break up my 7, and let me just write it below here so you can see, break up my 7 to 5 plus 2. Okay, now let's distribute this. So I'd have 5 times 7 to the k plus 2 times 7 to the k plus 2 times 2 to the k. Okay, so what do I have? I need to get, oops, what did I do? I changed my subtraction to an addition there, didn't I? Okay, so this should be subtract, 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 right? Okay, so remember, I need to use this. Do you see it? So 5 times 7 to the k plus 2, 7 to the k minus 2 to the k, there it is. I can take this and replace it with 5p. Then I can say, look at that, I can pull a 5 outside. 7 to the k plus 2p, therefore divisible by 5. A little trickier. I wanted to make sure I showed you this one. Okay, so now we move into a little more challenging ones, because notice there's an inequality in the thing we're trying to prove. That's what's going to make this harder. So just approach these with respect. You'll be able to do it, promise. Okay, prove for all integers for n's bigger than or equal to 3 that this is true. Okay, so let's first prove true, or show true for 3. So if I put n equal 3 in, I get 6 plus 1, which is 7, which is less than 2 cubed, which is 8. Check. Okay, so we're going to assume true for k's bigger than or equal to 3. So all the rest of them for k. So I'm going to have 2k plus 1 is less than 2 to the k. All right, so now showing true, now remember, this is what I'm going to use, right? I have to use this in my proof. So showing true for k plus 1. So put k plus 1 on the left-hand side, k plus 1 up in the exponent. Okay, so this gives me 2k plus 2 plus 1, so that gives me 2k plus 3. And then I'm going to break this up, 2 to the k times 2 to the 1, right? Again, you don't work with the right-hand side. I'm just rewriting it so I can see what it is. Okay, so thinking about what I want to use. I want to use this. So that's why I'm taking this 2k plus 3 and breaking it up into 2k plus 1 plus 2, right? So now I can take this out and put this in. So with an inequality sign. So let's do that. So here it is. So I'm going to take this left-hand side. I wrote it right here. I'm going to take this out, right? Take this out and replace it with a less than 2 to the k. A less than 2 to the k. And so this plus 2 carries along. So it's a substitution, but with the inequality, right? Take 2k plus 1 out and replace it with a less than 2 to the k, and then the plus 2 carries along. Okay, so what do I have? I have, so let me just write down again. this 2k plus 1 plus 2, right? That's this thing here, is less than 2 to the k plus 2. Now remember that we're dealing with integers bigger than or equal to 2. So don't I know for sure that 2 will be less than 2 to the k? Think about it. I know that 2 will be less than 2 to the k because k's are bigger than 2. So that's what I did. I took out a 2 and I put in a less than 2 to the k. So this here, don't pause there, right? Take out the 2 and put in less than 2 to the k. So let me erase here because now I want to show you what we have. So what we have is 2 to the k plus 2 to the k. Oh, that's 2 to the k's. Isn't that 2 to the k plus 1? And that's where I wanted to go. Yes. All right, we've dealt with factorials already. So let me just remind you, if you have k plus 2, factorial, that's the same thing as saying k plus 2 times k plus 1 factorial. Okay, so I'm going to let you do that one on Zoom.